Everyone following my channel knows that I'm working at the moment on a, say, battery watch circuit that has to watch over two 12-volt batteries here in series. So together 24 volts, and also here 24-volt batteries. They are connected to a charger circuit here, and I can read during the day how much current is, say, processed into the batteries. And here exactly the same. By the way, the setting of the charge voltage is very critical. I can pay attention to that in another video when you want to know that. But at the moment, let's say that the charging stops at 28.7 volts, 28.8, and also here the same. The warning circuit, the warning circuit is here. I've made a Schmitt trigger, that's here, and a beeper, that's here. They are combined. And when the Schmitt trigger made with two transistors tells us that the battery voltage is too low, the beeper must be activated. I have to say it was a quite interesting and, say, not beginner's circuit to make it, though it looks perhaps very simple. Not here, of course. It's a kind of haywire circuit, but I will show the schematic in a few minutes. And at the moment we read 24.8 or 24.9 volts out of these batteries. That's quite good. When you go to the World Wide Web and you study the, say, issues about lead acid batteries. These are lead acid batteries. They have very typical properties, and of course they may not be exhausted, completely depleted to a very low voltage, say 11 volts or so. They get easily damaged, say immediately damaged, when such a battery is depleted too much. So you must be very sure that that does not happen. Anyway, here is a circuit that I made. I don't show the beeper circuit here because it is not reproducible, in my opinion at least. I used, for instance, this print with here a unit on it that operates with ultraviolet light. Of course, no one in the world can find, for instance, such a unit. So, and I only publish on YouTube reproducible circuits. That's the aim of my YouTube channel, Electronics for Everyone. Anyway, so here is the circuit again. Schmitt Trigger is here. The Schmitt Trigger drives a green LED. You can also choose a red LED or whatever to indicate that the battery voltage is too low. I have to say the whole circuit is extremely critical. It's not a beginner circuit. Though perhaps it looks as if it is a beginner circuit, but that's not the case, because you have to align this potentiometer and this one and get the whole circuit into the voltage range where the Schmitt Trigger is exactly biased between two voltages. It must switch off at 24 volts. There are other voltages on the World Wide Web, but anyway, that's my aim. And when the voltage is high on the two lead acid batteries, the LED must not be activated. So you have a critical alignment of this potentiometer and this potentiometer and this one, etc. Of course, when you have a kind of fun in doing these things, just like me, it could be easy to find all the right settings of these three potentiometers to make the circuit work. Anyway, always interesting, these experiments, pin connections, and here again, and here again. And the circuit here is quite sensitive. Also a little bit, not too much, for hand effect. That's the reason why I mounted here a 220 nanofarad capacitor to ground. But it works properly. And of course, when the LED lights up on that specific voltage, you can activate via a light dependent resistor or whatever a beeper. And I've done that here with this part, but I don't publish that because it is more or less not reproducible. Anyway, the beeper circuit again, the voltage dropping down to 24.8 volts, and I hope that at 24.0 volts the beeper will start to work.